Honeycomb composite repairs to damaged panels like this can be easily performed in the field with the proper equipment and skills. Before attempting any repair, be certain you have the necessary gloves, protective clothing, and the appropriate eye and respiratory protection. To begin, lightly tap the panel around the damage site to determine the extent of the delaminated material. Once the area of delamination has been identified, mark that area on the panel. Then, measure these dimensions so that a template can be made, which will later be used to cut the fill plies. This template may either be oval or rectangular shaped, but the corners of a rectangular shaped template must be rounded to a ½ inch radius. After the template has been cut, place it over the damaged site and mark the area of delaminated material that must be cut out of the panel. Next, a series of repair ply templates are made, the first of which must extend 1 inch beyond the edge of the cutout area. The corners of each template must also be trimmed at a 45-degree angle, with the length of the angle being no more than 1 inch. The remaining templates must be cut to extend only 3/4 of an inch beyond the previous templates, with the corners trimmed at the same 45-degree angles that are no longer than 1 inch. In cases of full penetration, the number of plies needed to make the repair will be specified in the Structural Repair Manual, more commonly called the SRM, or in the engineering drawings. For partial penetration, the number of plies needed to make the repair will equal the number of plies damaged. Always remember, 1 repair ply will be needed for each damaged ply that must be replaced. Next, measure the distance from the edge of the cutout area, marking the location of each repair ply as well as the location of the sanding ply in order to determine where the Teflon tape barrier will be located. Then, place a strip of 2-inch wide Teflon tape around the repair area, making certain it is positioned just beyond the border where the sanding ply will later be placed. Next, begin removing the delaminated material by carefully cutting the panel with a radiac blade around the area marked for the repair. To complete separating the core from the rear panel, use a hammer and putty knife to gently cut the remaining core. Then, carefully remove the outer skin and damaged core from the repair area, making certain the composite panel on the opposite side is not damaged. Finally, complete the removal of the core and outer skin by using a barrel grinder to grind to the corners of the repair area, removing all loose particles, cracks, and delaminations. Next, carefully grind down only the peaks of the dried adhesive within the repair area, without grinding the residue adhesive footprints all the way to the panel, which may permanently damage the composite material. Thoroughly vacuum the repair area, making sure all debris has been completely removed. Then, taper the sides of the cutout to form a 45-degree angle that opens outward. Next, abrade the top surface of the entire repair area with a 150 grit paper, making certain you do not break the graphite fibers on the top surface of the outer skin. To prevent sanding too deeply, always consult the SRM to identify the paints and primers needed to complete the repair. This will also help to identify the color nearest the graphite structure. Following this, wipe the exterior surfaces of the repair with MEK or MIBK. Then, immediately wipe the surface dry with another cloth before the solvent evaporates on these surfaces. It's important to remember that MEK and MIBK must always be used in a well-ventilated area, and that protective gloves and glasses should be worn to prevent contact with your skin and eyes. When the surface has been wiped dry, use a heat gun to remove any residue solvent. After determining the type and the dimensions of the honeycomb core in the panel, cut out a core plug so that the ribbons of the plug match the direction of the ribbons of the surrounding core in the panel. Next, insert the core plug into the repair area. If the core is riding too high, as seen here, it will be necessary to trim the plug slightly to make it the same height as the surrounding honeycomb. Following this, cut a piece of fiberglass material substantially larger than the area of the exposed honeycomb. Thoroughly saturate the fiberglass material with resin that has been mixed according to manufacturer's instructions. Then, place a sheet of peel ply over the fiberglass material, making sure the peel ply has been cut larger than the fiberglass. Then, trim the peel ply so that it is approximately an inch or so larger than the fiberglass material. Place a sheet of non-porous parting film on a surface that can withstand temperatures greater than 200 degrees Fahrenheit. Next, turn the ply stack over so the fiberglass material faces upward, and position the stack at the center of the sheet of non-porous parting film. Then, place a sheet of porous parting film over the fiberglass stack. This is followed by one sheet of fiberglass bleeder cloth. Next, place a sheet of non-porous parting film over the stack. Then, position the heating blanket. Then install a temperature probe at the center of the heating blanket. Cover this with a sheet of RC 3000 breather cloth. Position a vacuum probe on the breather cloth. Then, place a sheet of nylon bagging film over the stack of material and seal the probe and the edges with sealant tape. Cure the fiberglass cap at the times and temperatures specified in the structural repair manual, while maintaining a vacuum of at least 20 inches of mercury. After the fiberglass has been cured, carefully trim the material with the peel ply still attached so that the fiberglass cap will be the exact size of the repair area. Mix the appropriate adhesive materials, adding micro balloons to thicken the adhesive so that it will not run. Then, apply the mixture to the panel and the edges of the honeycomb core on the interior of the repair area, as well as to the sides and bottom of the core plug. When inserting the plug into the repair area, be certain the ribbon direction of the core plug matches the ribbon direction of the surrounding core. Next, coat the exposed surface of the cap with enough adhesive to bond it to the honeycomb, making certain the adhesive is not being applied to the peel ply surface. Then, place the cap firmly on the repair area. It is important to have positive pressure applied to the cap and the core during the cure cycle to ensure a proper bond. One method of accomplishing this is to cut one or more rubber sheets, the exact dimensions of the cap, and thick enough to be slightly above the surface of the outer skin. After covering the rubber material with Teflon tape, place the tape side down over the cap. Then, secure the cap into place. Following this, position a strip of sealant tape around the repair area, at least 2 inches beyond the area of the heating blanket. Then, place a sheet of non-porous parting film over the repair, followed by the heating blanket. Next, place a temperature probe at the center of the heating blanket and secure it into place with tape. Then, position one sheet of RC 3000 breather material over the heating blanket, followed by the nylon bagging film and vacuum probe. Evacuate the air to at least 20 inches of mercury. Then, cure the repair at the times and temperatures specified in the SRM. When the cure has been completed, remove the bagging materials from the repair area. And finally, remove the peel ply material from the fiberglass cap. Before cutting the materials to complete the repair, you must first consult the structural repair manual or the engineering drawings to make certain the warp orientation of each ply matches the rosette pattern specified in these documents. To identify the warp orientation of the graphite material, some manufacturers have included yellow tracer strands of Kevlar, approximately 2 inches apart, to identify both the warp direction and the warp face of the material. On the opposite side of the material, tracer strands of Kevlar run 90 degrees to those on the warp face and are 6 inches apart. This identifies both the fill direction and the fill face of the material. Other manufacturers provide yellow Kevlar tracer strands 3 inches apart on the warp face only, and no Kevlar strands on the fill face of the material. To begin the final phase of the repair, apply a strip of sealant tape around the entire repair area, slightly more than 2 inches beyond where the edge of the heating blanket will be located. Next, pull out a sheet of non-porous parting film large enough to cover the work table. Then, cover this with a sheet of graphite material that will be large enough for all the fill and repair plies needed to make the repair. Make certain to identify both the warp direction and warp face of the graphite material before applying the resin. The warp toes, or strands, will always run the length of the roll, while the fill toes, or strands, will always run the width of the roll. After the warp orientation has been determined, mix the resin according to manufacturer's instructions in a well-ventilated area, making certain to wear the appropriate personal protective equipment. Next, apply resin to the graphite, working the resin into the weave of the material until it is thoroughly saturated. Then, cover this with a second sheet of non-porous parting film and smooth out all the wrinkles. Lay out the sheet metal templates on the material so that the warp orientation for each repair and fill ply matches the orientation called out in the SRM or the engineering drawings. The SRM for this particular panel requires the first ply for both the fill and repair ply be cut with the warp toes running in a 90-degree direction. The second set of fill and repair plies are cut with the warp toes running at -45 degrees. The third set of plies are cut at +45 degrees. And finally, the fourth set of plies are cut with the warp toes running in a 0-degree direction. Next, thoroughly saturate the fiberglass sanding ply fabric with resin, carefully working it into the weave of the material. Then, place a sheet of non-porous parting film over the top. Use the sanding ply template to cut the fiberglass material. The sanding ply will also extend 3/4 of an inch beyond the edge of the last repair ply. Before attempting to place any plies on the repair site, wipe and dry the entire repair area with MEK or MIBK to remove any debris. Then, thoroughly dry with a heat gun to remove any residual solvent. Following this, brush the cutout and fiberglass cap with resin so that the entire area is thoroughly covered. Then, remove one sheet of parting film from the first